to this session today. The session is on UAV remote sensing and its applications. So over the next hour, what we will discuss is how UAVs function as remote sensing platforms, compare them with satellite and aerial platforms. What are the different sensors and payloads used on the drone platforms? A little bit about the data acquisition and processing flow, and then we'll have we'll just show you glimpses or applications of these UAV data sets, including agriculture, disaster, and various sectors. So to begin with, as you all are aware about the remote sensing aspect, the remote sensing is basically observation of collection of data from a distance. So there are three common platforms which are there in remote sensing. One is the satellite-based platforms, aircraft-based platforms, and ground-based platforms, right? Which has been traditionally been used. Each of these platforms, if we talk about, are assessed in terms of 4 metrics, which you all are aware about it. That is spatial resolution, temporal resolution, spectral resolution, and of course, the 4th one is radiometric, which is slightly different. But primarily, we talk about is the 3: spatial, temporal, and spectral, and the operational cost. The flexibility and cost is another metrics on which we will try to compare these different platforms. Now, satellite-based platforms, as you are all aware, is a platform which provides a good spectral and a temporal coverage, right? We have a large range of spectral variability data sets like multispectral, hyperspectral, thermal, but the spatial resolutions is in meters, and to some extent we have now in centimeters also, but with limited coverages, which is there, to sub-meter, which is also available. It is very useful for regional long-term monitoring, but limited when you need centimeter detail on an immediate on-demand data set. So they have a repetitivity. They have one time period when the data is collected. So if you require a centimeter detail level immediately, then it becomes difficult. In comparison to this, we have these manned aircrafts, or it is airborne aircrafts, which gives you a very high spatial resolution and large swath widths. They are more flexible than satellites, that as and when you want, you can fly these aircrafts and collect the data, but they are expensive, costly, and it's very difficult to mobilize and operate them. Instantly, you can't think of it, fly. So they need a certain preparation time. So if you want to cover a city scale or a corridor level mapping, these are good enough. They provide you good data sets. Then we have the ground-based platforms. The ground-based platforms, which have the highest resolution, and the coverage is very small, but it gives you very detailed information about the object. But they have a limitations that you can't collect the data at larger scales. You have coverages in a very small area. And these data sets are used for calibration and validation of both air-based and space-based observations. So in between the ground and the air-based, we have another platform which has of late recently been widely used in the remote sensing community, is the unmanned aircraft, or what is more commonly known as drones. These drones, they are filling the gap between the aerial and the ground platform, and they provide centimeter to a decimeter spatial resolution. And the main advantage is you can, fly them as and when you want. So on demand, you can collect the data, and the data collected is at low cost also. The cost as compared to the aircrafts is much low. And you have the ability to mount a wide range of sensors, like whatever data you want. Not only what is there in satellite, you have fixed sensors on a UAVs. You can mount the sensors based on your requirement. And they are very useful when you need or when you want high detail, rapid response or frequent monitoring at a local scale. So when you want very high resolution for a very small area and a frequent coverage, then instantly you can plan and fly. The cost is less and you get the desired data sets. So a technical trade-off, if I say so, if you talk about the satellites, they have an advantage that they cover a larger area and they have a good repetitivity. Aircrafts, they have coverage is also a larger coverage and the resolutions is very high compared to the satellites, but the cost is very high. So whereas the drones, they have the finest resolutions, they are more flexible, best for localized, high frequency, and post immediately a disaster happens. So the most significant advantage of drone is, suppose there is a disaster and we don't have a satellite pass in that area, instantly we can fly the drones and collect the data. So when data requirement in case of disaster, you need instantly or immediately the data to assess post disaster damages or for rescue operations, drones comes into handy. Another advantages of drones is each satellite has a fixed geometry. So they are designed to, the satellite positions are fixed. So, and the sun angle positions vis-a-vis the satellite position is fixed. So in very high altitude zones, most of the areas, if you talk about satellite collects the data between 9 to 10:30 a.m., some of the areas are in shadowed regions. So consistently you have some data sets in a shadowed region. So drones is one where you can fly the drones in these areas where there are shadows and collect the data to fill the gaps in the very high mountainous hilly terrains. Right? So now, when we talk about drones, now what are these drones? As we said, the drones are mainly in three mechanical types. I mean, the drones classification in India or globally also is divided into, is based on three major categories. One is based on the weight size, the range, and the aerodynamic capabilities. So there in India, based on the weight size, there are 5 major categories. One is known as less than 250 grams. These are called nano drones. Between 250 grams to 2 kgs are micro drones. Between 2 kgs to 25 kgs is mini drones. Higher than 25 kgs, larger than 25 kgs, and less than 150 is small. And the larger than 150 kgs, they are known as large drones. So each of these drones, the weight which I'm talking about is including the sensor weight, the maximum takeoff weight. So overall, including all the weight and size of the drone, these are categorized as nano, micro, mini, small, and large. And this also we'll talk about later how the guidelines for the drone or drone policy governs which kind of permission is required to which kind of drone categories. The other classification strategy is based on the range capability. So the close, and this is in a way interlinked to the weight and size of the drone. Smaller the drone means lighter the drone, the battery power is also less. So it is not able to fly for a longer duration. It's maybe 250 gram drones has a battery capability of maybe 15 to 20 minutes. So it cannot fly a longer or a larger distances. So that is there, the range it can cater to. And the heavier weight drones, which have a considerable battery power, they can fly at a larger distance and for a longer duration of time. So based on this, they are categorized as close range, which can fly for a very short distances, short, medium, and a long range drones. So weight and size and range are in a way interlinked to each other. Then the next category is based on the mechanical operation of the drones, which is categorized as fixed wing and the rotary wing. And there is a third category, which is known as the hybrid drones. So the fixed wing drones, they are like the aeroplane. If you see on the side of the right side of the photograph, It looks like a normal aircraft. It's an airplane style. So these have a longer endurance. They have a better stability, better power, and they can fly, cruise at a speed and cover a larger area. But the major disadvantages, or I mean, the limitations of this kind of uh, the drone is type of drone is that it requires a runway. So it needs a space to do a takeoff, like what we do on an aircraft when we fly. It has a runway. So these kinds of fixed wing drones, they require a runway or a catapult. Catapult is a mechanically platform where it is used as a runway for takeoff and landing. Right. So these platforms, the other category is a rotary wing or a multi-rotor kind, which looks like a helicopter. So these rotary wings platforms have a limited battery power, and so hence they can fly for a limited duration. They can lift very small payloads, whereas the fixed wings can carry a larger payloads also. So the weights also can be there, and but it has an advantage that they can take off vertically and land vertically. So the vertical takeoff and landing can be done with a rotary kind of wing. So from any one point, you can fly and take off and then land it also at a point. So it doesn't need a runway. So depending on, so both of these platforms, both of these kinds of drones have their own advantages, and they can be used for different applications. So fixed wing is used best when you want to have a larger area coverage, and also when you are trying to fly in an area which is flat, where you have a sufficient space for takeoff and landing. And that's why if you talk about large agriculture surveys or cadastral corridors, then fixed wing drones would have a very greater utility. The other way around, if you are wanting to have a small area to be mapped, and you want to map in an undulating terrain where there is difficulty to find a place for takeoff and landing, then in those cases, multicopters can be utilized, or quadcopters, which is there. It depends on the propellers, which it has. If it has 4 propellers, it's called as quadcopters. It has 8 octocopters. So depending on that, the power of that propeller, based on the propeller numbers, the power of the rotary drones is increased. So the advantage of the vertical takeoff landing comes into when you are using in an area where there is limited area available for takeoff and landing. So they have an advantage that, and also these rotary wings can stay stationary at a point, whereas a fixed wing continuously cannot be kept stationary at a point. So if you want to monitor at a point, keep it stationary at one point, it can stay stationary, the rotary wings. They can also be tilted. And for example, if you want to monitor a building, you want to take a 3D of a building, so you can rotate the rotary wings along the 360 degrees of the building and collect the data, whereas the fixed wings can fly only in a vertical direction. So they cannot be tilted in any oblique angles. So this is another advantage of the quadcopters. Then there is a third kind of drone combination which has come, and based on the is a combination of the fixed wing and the multi-rotors, which looks like a fixed wing but can be operated, which has the capability of a vertical takeoff and vertical landing. So it's a combination of both. Looks like fixed wing, but it can be released from a fixed point, so you don't need a runway, but all other properties remains for a same as the fixed wing, that it cannot be stationary at a point, it cannot be tilted. But the advantage you get is that instead of a runway, you can do a vertical takeoff and vertical landing, and you can cover a larger area. So these are the different types of platforms which is there. So you have earlier when it started, you had these motorized kites on which the cameras used to be placed. Then helicopters with a single axle, coaxial helicopters were there. Then fixed wing. And in between this, you see, this is the hybrid kind of a drone platform, which looks like a fixed wing, but it can be hand, thrown, and it can be captured at, it can be landed at a point. And these are the rotary. So this is, if you see the propellers, there are 8 propellers. So this is a octocopter. And the power of this rotary platform is much higher than the quadcopter, which has 4 propellers. So you can carry much more sensors and the weight on an octocopter as compared to a quadcopter. So here there are different types of the multi-rotor wings, which is there. You have a quadcopter, you have a multicopter, you have a hexacopter, and a octocopter. So this, as we had already discussed, the limitations and the advantages of the different models. So which we said, the multi-rotors, they have short flight times, small payload capacity, but easy accessibility, easy to use, vertical takeoff and landing, and they can stay stationary at a point and can operate for a smaller areas. Fixed wings, they have a longer, you can fly for a longer distances and longer time, cover a large area. The flight speeds are they are more stable platforms as compared to the rotary wings, but they need space for taking off and landing, and flying them also needs a specialized training and slightly expensive as compared to the rotary platforms. Then there's one which is a fixed wing, a hybrid platform, which is a combination, as I said, of both, which is a hybrid platform, which is a vertical takeoff and landing. It can fly for a longer distance, but it cannot stay stationary at a point. Then there's another one, single rotor, which can have like a helicopter, which can have a vertical takeoff and landing, can stay stationary at a point, can have a longer endurance, and they can carry a heavier payload capacity. But sometimes it's difficult to operate these kinds of platforms. Now, if we talk about the components of an UAV, as we see, is a combination of hardware, sensor, and control systems. It's a key components. What it consists of: a frame, a motor, a propeller, right? The electronic, speed controller, flight controller, battery, transmitter, a receiver, GPS, and an IMU, sensors, and a gimbal, which is there, and of course a ground control system. So the most visible part is what we can say is the frame, which is the skeleton base, the frame on which every component is fitted into. So which acts as a skeleton bones of the UAV, which defines the shape and the strength of these drones, whether it's a rotary, quadcopters, hexacopters, or fixed wings, and all depends on the design of it. So these frames, material of these frames are usually lightweight, durable materials like carbon fiber or composites. And mounted on the frame are the motors, which acts like a muscle of the drones. So without them, flight is not possible. So motors are required. So more the power of the motor, the more the lift and the stability. So, and then and these motors spin the propellers, which generates the, which generate the thrust, and it lifts the drones up. So propellers are nothing but the wings of the drones. So their size, angle decide how efficiently the drone can fly and carry the payload capacity. So as I said, if you have 4 propellers, then weight carrying capacity is less. If you have 8, then it's higher than the 4. So the propellers are arranged in clockwise and counterclockwise pairs to balance the torque and keep the UAV stable, right? Between the power source and the motors, there is an electronic speed controller. This device regulates how fast each motor spins, and it acts like a messenger. It ensures that the motor spins at the exact speed required to keep the drone in balance. And based on this commands it receives, and it is based on the command it receives from the flight controller, right? So the flight controller is basically the brain of the drones, and it is the one which makes the decision. So it ensures that the drone stays level and reacts instantly to pilot commands on environment. I mean, any kind of changes, any kind of modifications which the pilot or the one who's operating makes it. So it takes inputs from the onboard sensors, which is placed, which is like the gyroscopes or accelerometers or IMU, and then calculates how to keep the UAV balanced and move in that particular direction. Then to have a power on this, your drones have the batteries, and generally lithium polymer batteries are used. Nowadays, there are drones being designed for having fuel, petrol-based or solar-based drones are also coming up. Okay. And the power of these batteries decides how long or what would be the duration of the flight, how much time the drones can fly. And to control this, we also have a transmitter and a receiver, which is basically a communicator between a bridge between the person who's operating it and the drone. It is the one which communicates. So without them, the operator has no control over the aircraft. So the pilot sends the commands through these transmitters, which are received by the UAV, and then it is passed on to the flight controller. Then the further action is given to the motors, and accordingly it's done. Along with this, see, there is a GPS module. This GPS module is required on a drone to provide where to move, to tell you need to fly or collect the data in a field. So where to move. So it provides the location and the height information to enable the drone to move in that particular direction, collect the data and return back to the ground. Okay. So along this GPS, there is an inertial measurement unit, which measures the stability of the platform, that is the tilt, orientation, and acceleration, and to ensure the stability even in the windy conditions. And then the drones have a sensor. You need a sensor to place it on board the drone. So they have these sensors. To keep these sensors in a stabilized way, there is something called gimbal. If you see on this side, this is a gimbal on the board, which is a mount which stabilizes which fixes the sensor. It keeps so that the motion of the drones and the sensors it's not impacted. It keeps the sensor fixed so that there is no motional effect on the data which is collected. So in general, gimbals are what you can say stabilized. It makes this platform for the sensor more stabilized. And then finally, we have this what we called as a ground control station. This may be a laptop or a tablet or even mobile terminal full control console, which is being operated by the operator on ground, from where he can plan the complete mission that mission of the aircraft, where it will collect the data, what will be the area of coverage, what will be the spatial resolution. So all this flight planning is done using this ground control station. And he can also receive live video, real-time video, while the drone is moving in the air. So all these units, which is the frame, motors, propellers, flight controllers, battery, transmitters, they are integrated together and they work in harmony, and then we are able to collect the data sets. So another few more features which are there along with the major components is on drones which are required and is essential is the obstacle detection and collision avoidance technology, so that bird hitting can be avoided. So once it finds certain objects closer to it, the drones move away from there. So a sensor is placed on board the drone so that to avoid obstacle, it will detect any obstacle coming or any object coming closer it, and it can move away from that area to avoid collisions with that object and harm to or damage to the drones. The other, which I already talked about, gyroscope stabilization, IMU, and flight control. If you talk about a normal drone for a photography, they may not have this one, which is a cheaper versions, but when we use it for remote sensing applications, the gyroscope stabilization and the IMU are essential components. which provides the essential navigation information and also detect the or maintain the stability of the platform, right? Then the ground control station, as we talked about, and the gimbals, which is very vital in terms of remote sensing, so that it allows the camera to be fixed at a point and collect data and reduce, so that the data collected does not have a camera vibration due to the, is not having blur effect due to the motion of the drones, right? Then once the drones are, then the next component which is there, the major components which makes, are based on which we are using these drones for the remote sensing applications are the sensors on board the drones. So the payloads define what is the data you collect. The common categories of drone sensors which are available are RGB, multispectral, hyperspectral, thermal, LiDAR, and specialized sensors like gas sensors, SAR prototypes or microwave sensors, which are also in beginning to come up in the being developed. So RGB cameras, if we talk about, are the normal visible cameras, which is one of the most common payloads used in drones, and they give you a very, very high resolutions. They come up around with the specs of 12 to 50 megapixel sensors, which leads to a ground spatial resolution of 1 to 10 centimeters. And that again depends on the flying height. So they can be used for, simply a damage assessment or mapping applications, and they give you a very, very high resolution data sets. The next kind of sensors which is available are the multispectral sensors, which capture the data in discrete bands. So you may have 4-band sensors, 8-band sensors, or 10-band. There are a large variety of multispectral cameras which are available in the market. And using this, you can calculate the various indices. You can use it for various applications which are there in the remote sensing arena, whether it's agriculture, vegetation, geology, everywhere these can be applied to. Then also along with this, we have what is called as the hyperspectral sensors also available. Lightweight hyperspectral sensors are also there for the drone platforms. They can collect hundreds of contiguous narrow bands. And the main advantage, as you know, for hyperspectral sensors are, that is, the material discriminations, the species level identification for mineral mapping or chemical stress detection. So they have an advantage because you have a large bands which is available. But the main problem is the large volume of data. And if we mostly the hyperspectral sensors, which is up to the near infrared, are lightweight. The moment we have the shortwave infrared also included, the weight of the payload is slightly higher, and cost as compared to the RGB and the multispectral is higher, and the processing is also slightly complex. Then another sensor which is available is the thermal infrared sensors, which measures the temperature of the land surface features, and it requires, calibration is required when you have thermal infrared sensors. So these are also lightweight sensors are available. There are also LiDAR sensors, which is LiDAR is light detection and ranging, which is used to calculate the height of the object by emitting laser pulses and returning and measuring the return pulse time, and then multiplying using the speed of light, we can determine the range, and based on the range, we can calculate the height. So using this LiDARs, we can estimate the accurate terrain height, vegetation height, building heights. So they can be used for a wide range of applications. But again, LiDAR payloads are slightly heavier and often flown with a larger fixed wings for a better stability in place of a quadcopter, in case of a rotary platforms. But also rotary platforms can also be utilized. But as I said, the weight of the payloads is slightly higher, because when you have drone, you should also have another GPS module having an RTK or a PPK capability along with the LiDAR sensor. Then there are many emerging payloads which are also included or available, or you can design your own payload capability. And fly on a drone depending on your applications. So there are small SAR sensors are also there, which is having an advantage, its own specific advantages. There are gas sensors for leak detection, radiation detectors for hazardous site assessment. So there are a large number of sensors, air pollution sensors, temperature and pressure sensors. So how do we choose a sensor depends on the kind of the research you are following or the requirement. Based on that, you decide on the sensor, then you decide on the payload and the platform. For example, if you talk about, if I can give an example of a crop stress at a plant level, I mean, we want to find individual plant, the stress in a plant, then I need a multispectral data sets to find the stress in a plant, spatial resolution of 5 to 10 centimeters, and I can have any, depending on the terrain, I can choose either a fixed wing or a quadcopter. If my terrain is flat, a large area coverage, then I go for a fixed wing. If it's in a hilly terrain, then probably the rotor wing can be of more use. So this is primarily the remote sensing based, drone based hardware and software required for drone based UAV remote sensing, the hardware and software. So what we need is a drone with the required instrumentations, which we talked about, the payloads. Then along with this, we need a mission planning software, which is inbuilt into the ground control station. Then we need a good GPS. The GPS can be on board. Or else, when we have an onboard GPS, the weight of the drone increases. So to make it cost effective, you can have a ground-based GPS, and drones can be without this. One GPS is required, that is for navigating the path of the drone, which is essential. The other to geotag the images which you come for georeferencing the images which you are collecting. Either you can have an onboard GPS or you can have the GPS on ground, so that your data is properly georeferenced. Then, since the volume of the data with the drones is quite large, when we are talking about 1 centimeter level data sets, so we need a powerful workstation to process this data. Along with this, a hardware or a laptop can be required to monitor or to validate the data which you collect on the ground. So as we said that the overall workflow for the drone is data collection and processing is, which first includes the mission planning, that whatever the parameters you define based on your application, the mission plan needs to be uploaded on the ground control station. Then you acquire the data, pre-process the data, then analyze the georeference the data, do the analysis, and then visualization based on that. So the first part of the data acquisition is the mission planning part, which is the most significant. In the mission planning, you design the entire plan of it, what kind of data is to be collected. So what type of the project is? The project is aerial, terrestrial, or mixed. So aerial means you're trying totally vertically, you're doing a vertical flight. Terrestrial means there is an oblique viewing also. And mixed is some data is collected totally vertical, some is with an oblique angles. So depending on the application, if it's an agriculture area, you may do aerial. If it is a highly residential built up areas where high-rise buildings are there, or maybe in a certain angles in a very mountainous terrain, you can go terrestrial, or in a built up high-rise building areas, you can have a mixed plans also. So then type of the terrain, type of the object which you want to do, the type of the camera or the sensor payload which you're going to use, whether the path of the data collection is in terms of a circular, grid, rectangular, regular, what kind of data is to be collected, what is the area of your coverage, the acquisition strategies also needs to be defined. So in the mission planning part of it, which involves the various key parameters. So there are a lot of commercial softwares which are available. And even if you buy a drone, along with it, that drone, they give you a mission planning software. So ensure that you have this software to plan the entire data collection strategy. based on which you will collect the data, because if it is not correctly planned, then the data acquired may not be of proper use. So the key parameters in a mission planning software is what you need. You need to define the area, the terrain in which you want to fly. The area covered is a regular rectangle, square, or an irregular polygons. You define that. Then you also define the key parameters like what will be the GSD, the ground sampling distance, that is the spatial resolution. And depending on the spatial resolution, you define the flying altitude. Then if it is for photogrammetric applications, you also define how much should be the overlap between the two photographs so that I can generate a three-dimensional perspective, or you can estimate the height. So is there a front overlap, and how much will be the side overlap? So generally, typically, we have 80 to 90% of the front overlap and 60 to 65 of the side laps. Then based on that, you also plan how much area is covered, what time is there. You also define the flying speed, because if you fly very high at a very high speed, it may affect or create a motion blur in the data sets. Then what will be the camera trigger interval, and what will be the flying orientation? The flight will be horizontal, vertically, how it will be flying. And you also, this flying times which you fly, whether it's going to go in this direction or in vertical directions like this. So what will be the path flight orientation that you will define. And accordingly, if you have an onboard GPS for georeferencing, it's okay. Else you need to plan on ground to collect the GPS, GCP data sets simultaneously to decide where to keep these ground control points so that they can be utilized effectively for georeferencing and correcting your data sets. So if you want a very, very precise output from the, and that is what is the requirement using drones, is you need to have a survey GPS receivers, which is a real-time kinematic or a post-processing kinematic GNSS receivers. They can be directly integrated with the drones, as I said, on board. The cost of the drone and the weight of the drone slightly increases, or you can have them on ground itself. So depending on that, if you have it on ground, you can collect, you need 5 to 10 GCPs, depending on, again, the size of the area, for properly geocorrecting your data sets. And generally, the data should be collected at very low sun angles, right? So that you have a good light conditions, and ensure that you also define the flight time durations depending on your data area, the spatial resolution, the battery power. The mission planning software will automatically calculate for you what will be the flight duration for the entire area coverage. So if your battery power is, suppose, say 20 minutes, and it takes 1 hour to cover the whole area, then you know you have to bring back the drone back, recharge the battery, and collect it in multiple flights. So you cannot collect the entire area in a single flight. So it will tell you how many flights are required to cover the entire area. And if you are using the multispectral and hyperspectral data collection, for RGB, nothing is required, but for multispectral, hyperspectral, calibration panels are also to be used to calibrate your data collection at the start and the end. That is, a radiometric calibration is required during the flight data acquisition. So these are the few photographs which you see. Some are collected nadir and some are oblique photographs of the Bhagirathi here in the Bhagirathi river here in the Uttarakhand region. So once the data is collected, then we operate using photogrammetric workflows. We use different approaches, like now another algorithm which we call as structure from motion and multi-view stereo algorithms to align the images, because these images, if you see, are with different orientation. How much is the overlap? So all of them needs to be aligned, compute the tie points so as to stitch them and make a complete mosaic out of it, right? And then apply photogrammetric processing to extract the the height values, which is the digital surface models or digital terrain models. Then based on this, ortho rectification is done, and true mosaics or true ortho mosaics, which is free from both relief and tilt distortions, are generated, and which can be further analyzed. For like example, if it's a multispectral data, you have a now ortho mosaic created with all distortions. You can create NDVI, do other further analysis on the data, and extract the information as per your requirement. Similarly, if it is a LiDAR data, the processing steps are slightly variable. But in case of, again, multispectral and hyperspectral, we need to also calibrate radiometrically the data collected. So that's what I said. We need a calibration parameter so that the data is properly calibrated. You have the reflectance data, which you can further analyze. We do a little bit pre-processing. So this is sample images of the drone collected using different sensors, RGB sensors, near infrared. See, this is a 5-band multispectral sensor where we have the data in the red, green, blue, then near infrared, red edge. This on the right hand side, you see a data collected using the thermal sensors, which is collected both during day and night, which gives the temperature. And this is the false color composite generated out of the data. So this is some outputs, and this is how the mission planning was done. This is from the point the drone flew, and then it flew along the path, collected the data, and this is so takeoff and landing points are well defined in the mission planning software, and accordingly the red dots tell you from where it clicked the photographs, so the capturing points along the flight, and this entire area was captured here this way. This is the multispectral data set. So as I said, we need to calibrate the sensors. From the radiance, we convert it to a reflectance data. So finally, what you have the reflectance, which then can further be used for further analysis. So the both hyperspectral and multispectral needs calibration before you use the data for further extraction of information. So similarly, thermal data also needs to be calibrated to calculate the exact land surface temperature values. So the initial before calibration gives you a high range of values, which is the radiance values or the DN values. And then accordingly, they are calibrated and converted into the actual temperature values, which gives you the real temperature. So here it's like the highest here is around 42 degrees. And here in the lower images, it's around 37 degrees, 0.32, or 37.32 degrees. So once the data is processed, so after processing, we can derive a large amount of outputs. So we can have orthomosaics, digital surface models. We can derive, a relief map, 3D perspectives. We can extract any kind of thematic layers, like we can detect trees. We can create a vegetation map. We can create a land use land cover map. We can do estimate the health of the plant. We can do a thermal anomaly detection in terms of if there is energy. We can create, if a build-up area, we can create a complete 3D scenarios. And or we can detect the stress in the vegetation. We can do volume calculations. We can do change detection. So any kind of analysis, or we can extract information from the data once the data is pre-processed, ready, and an orthomosaic is created that is ready for further extraction of information. Now, remotes, now if you talk about the UAV remote sensing applications, there are a wide range of applications where drones can be used. They can be used in various sectors, like we can have a complete topographic maps can be created at a very large scale. They can be used for mapping the terrain, creating a complete 3D, managing the infrastructure projects. The data which can be generated can be the extracted information, can be directly ingested into a GIS environment for further applications. It has a wide range of applications in agriculture, because nowadays in India, drones have now become a game changer in the field of agriculture. And they are used for crop growth and yield monitoring, precision agriculture. We'll talk about some of them. Crop insurance is one area where drones have a very significant advantages. The others, as I said, for infrastructure development, projects monitoring, corridors like power line monitoring, cultural heritage monitoring, if there is any damage or disasters creates, there is a damage in the cultural heritage sites in case of disasters. In disasters response, immediate data is one of the highest value, highest requirement, and in that case, drones are very, very handy. They provide a rapid data collection. They also assist in search and rescue operations, and the post damage assessment also is very quickly can be done using the drone data sets. Then forest fires, wildlife monitoring, emergency services, in case of mining, all these sectors, drones have played they have a very vital role to play, and they have been used. So I'll try to give a glimpse of few applications or data which we have also carried out, and some examples of it is this high resolution mapping, very, very high resolution mapping and topographic information extraction using drones, where you see the kind of information which can be extracted. This is a data which is collected from a drone with an altitude of around 600 meters from the ground, and it is somewhere near to Dehradun area. So from this data, you could see that we could create a topographic map of 1:2000 scale and the contours of 1 meter interval. And using this, we could also create a bare earth model. That is, bare earth is required for various geological and other topographic information extraction studies where you need a slope, you need to calculate for creating a drainage in an area. That is, bare earth model is the height of the terrain minus the artificial or man-made or features like buildings, trees, everything. It's the bare earth height. So the point density or the resolution is such high that we can generate the bare earth model even from a drone multispectral data sets or RGB data sets, whereas earlier this was only possible with LiDAR. So LiDARs are expensive versions of from where these model used to be extracted, but it is possible with high resolution RGB cameras from a drone-based platform. So in this case, if you see the here, it is able to identify a fault line, a lineament here in the terrain, which was covered with the vegetation features. So minus the vegetation features, one can see the terrain geometry, terrain features much clearer, and 1 meter level contour. Here it's an orchard area, mango trees. The contours on the various tree heights at the level of the tree is also can be visualized very clearly. The slopes, very subtle slopes are also mapped using the drone data set. So this is what is there, the range of slopes which we could map, and this is it could generate a very, very accurate information in the very, very small slope, slightly slopy area lands also is there. So this is for another area where we tried to generate the data, 14.5 centimeter resolution, spatial resolution. And this is a simple comparison of the digital elevation model generated using drone and a Cartosat data sets. Cartosat, it has 2.5 meters from a space-based platform and a drone. So you can look at the terrain relief, the micro relief in the terrain can be visualized with drone, which is lost in the Cartosat. And when we try to compare the drone-based height, the height estimated using the drone with the GPS, which is the ground-based height, determined from the GPS data sets, they were comparable. They were quite close to each other. The overall, RMSE, or the difference between the elevation estimated using the drone and the GPS is around 26 centimeters. So this is another comparison with Cartosat. So large variation you see with the Cartosat data sets between the heights, whereas the GPS data and the drone data sets are comparable to each other. This is the example where we extracted 1 meter contour. So there are buildings, there are different height within a building. If you have multiple floors, variations are there that also could be captured with this kind of data sets. This is the bare earth extraction, which I said. But then we compared this data also with the terrestrial lidar, which is a more accurate ground measuring instrument. We calculated the area and the perimeter, which is done on the ground, and compared it with the data collected from drone and estimated the area and the perimeter. Again, the differences between the two was in centimeters, and it is very, very accurately representing the terrain features. This is the profile along the, steppe agriculture or the terrace agriculture. So here also the data collected using the ground and the drones were comparable and matching to each other. So this is another example where we showed the topographic map at 1:2000 scale generated from the drone platform. So drones can also be used. I mean, from here you can also, the data sets is so high, it gives you volume of, so high precise resolution, where you can do kind of information extraction in which you can extract each buildings, trees. You can count the number of buildings, you can count the number of trees. This is one example in different kinds of populated regions of the city. One can easily count the number of buildings and extract the building boundaries also. So this is one example. Then this is the mango orchard. You can see a lot of variability between the mango orchards. So we can estimate the health of the vegetation. Along with that, we can also extract the height of the trees. So for kind of doing an orchard management, one can know the health of the plant as well as the total number of trees, and you can assess, and it's very effective in doing. So here, AI-based information extraction algorithms can be applied to extract the buildings, the roads, the trees using a very high resolution drone images. This is one example where we tried to see like a lot of the monsoon season, you say the river, a lot of water comes, and along with the water, sedimentation is also, sediments are also coming and getting deposited along the river plains. So this one exercise which was done to estimate, quantify the sediment deposition in a small, seasonal river, where before the monsoon and after the monsoon, how much was the deposition of the sediment. This is one example of that, where this can be precisely done with the drones, where it is not possible to do with the space-based observations because of the spatial resolution. So it require a very, very high spatial resolution. Drones are very, very effective in case of disasters, because in all kinds of disaster applications, all phases of disasters, drones have a very significant role to play. They are used in pre-disasters so that they can prepare a good high-resolution database, and that can be used to prevent or do a kind of an early detection during the disasters for mitigation, monitoring, and relief rescue operations, which we have seen in Uttarakhand last year in various areas. When people were trapped in the tunnel, drones were used for finding where the people were trapped and for relief and rescue operations. Post-disaster, it's very handy because instantly we can collect the data and estimate where are the damages, and accordingly actions can be taken. So they are very, very useful specifically in case of drones for landslide studies and monitoring. This is one of the most common areas where drones are having its vital applications, because once when a landslide occurs, the first information to be provided is the extent of the area affected by the event, right? So the landslide impact extent can usually analyze based on the optical images which is acquired. So many a time satellite passes are not there, so immediately drones can be used to fly and collect the data, and they can be used to see where are the damages, what are the impacted areas, and do a post-event analysis. So this is one small study we did for a landslide in landslide-prone area in Nainital, which is the Balianala. So you can see the weather, the condition of the weather condition. How was it? It was a very foggy weather on that day, a lot of fogs. But since drones can fly at a very low altitude, we could get a clear cloud-free, clear vision of the terrain, capture the terrain, and estimate this is a landslide. So basically, this was done to estimate if what is the if the landslide triggers. So which are the areas which will be impacted? So the state government can take remedial measures or immediately pre-warn the areas to vacate those areas and create further action so that to prevent the landslides in future. So this is one area you can see. This is the complete mapping of the landslide prone areas which was done, and this is the kind of details which was captured, very minute details, and a 1 meter level contours were there, and those areas which are could be impacted by the landslide if it is activated was identified, and then government is also taking measures to how to prevent it further by creating some measure management. Here is another one where we try to do a modeling here, a flow modeling, where try to estimate that if a landslide is triggered, because if you see from a satellite based platform, when we generate, the satellite collects the data on another view, so the information along the slope is generated, but the accuracies are very poor. And in this case, we flew the drone along the slope, along the direction of the slope, so we get the precise slope values or slope parameters of this landslide, and we tried to model and see. We compared it also with the digital elevation model generated from a satellite based data, that if a landslide triggers, then at what rate and with what velocity the debris will flow, and which are the regions and what area it will reach, and which are the regions which will be impacted. So this kind of drones provided, the data collected from the drone is very high resolution, and we could fly along the slope, so the information which was much more precise. So it gave a real picture that if the landslide is triggered, this is the rate and the flow of the debris. This was the area which will be impacted up to how much time. So the state can take action and create an early warning to the people from there to evacuate before, so that it can prevent, it can save lives during this operation in case of if a landslide is triggered. Then this is another example where it can be used for the cultural monument preservation kind of activities. You can this is one example in Myanmar, where there's a temple which was impacted by the earthquake in around 2016, damaging the archaeological site. And this is a satellite based observation which you see, where due to the, again, as I said earlier, the geometry of the satellite and the angle is fixed, and the viewing angle, and because of which the area which was affected by the earthquake is lying in the shadowed region. So no information is available. Drones was used to collect the data. So with the drone, you have the flexibility to fly across everywhere, collect the data, and assess the damages. So drones, which provides a multi-directional view, it enabled us for a clear visualization of the damage and the debris. So we can do a damage assessment both in the shadow and the non-shadowed region, and estimate, and accordingly remedial measures can be done. So this is another example where Leo Stanlin, they published a paper where they did a study on a sand quarry monitoring in Tamil Nadu, where they used the drones with the DGPS to generate an orthomosaic map and the digital terrain model, and they calculated the 3D volumetric estimations. So they showed that the actual sand removed was much greater than what was authorized, what was approved between the approved limits, leading to both the revenue loss and environmental impacts. So for basically administrative purposes, this is very useful. And the major environmental impact was changes in the riverbed and the erosion. So compared to the manual surveys, drone-based surveys, they were much faster, quicker, accurate, and they provided a much clear visual evidence. So action can be taken. Sand quarry is allowed, but within a limit. So if somebody is doing beyond a limit, so actions can be taken against them. So this technique is very, very highly effective for auditing and sand mining and ensuring the compliance is there. And in case of agriculture, as I said, drones have a very vital role to play, and it's been a game changer in the field of agriculture, with an application spanning from the crop insurance, crop monitoring, soil assessment, crop protection and fertility management, crop insurance, irrigation and drainage. So by providing timely and accurate and cost-effective data, drones support decision making, which enhances productivity, reduces risk, and promotes sustainable farming. So in terms of crop monitoring, I would say the drones, which is equipped with multispectral, hyperspectral, they can generate large amount of data, which can allow us to assess the plant health, chlorophyll content, and growth stage. Even an early detection of pest infestation, nutrient stress, or water deficiency, so that timely intervention can be done. Then in soil assessment, drones supports a certain, you can create a very high resolution digital elevation model and slope maps, which guide the land preparation. Thermal sensors on board, when placed on the drones, data collected using thermal sensors can identify the soil moisture variability, supporting in precision irrigation planning. Soil organic matter and texture can be indirectly mapped with drone multispectral data sets. So this information is vital for for farmers for applying variable, depending on the requirement, the fertilizers, the pesticides, whatever they want to do, accordingly they can apply. Then in drones fitted with spraying modules can apply pesticides, herbicides, fertilizers in a targeted and a more precise manner. It can also help to identify the phases and health of crops during different stages. So accordingly, right amount of these pesticides, herbicides, fertilizers can be sprayed. And hence, this reduces the chemical consumptions, prevent overuse, and minimize the environmental damages. So basically, nutrient stress zones identified through spectral data can be site-specific treated, ensuring optimal fertilizer management. So farmers can have both cost and time saving and ensure a better crop health and yield. Drones also play a very important role in agricultural insurance to assess the damages which is due to floods, droughts, or any other environmental conditions. So the high resolution images provides clearly objective evidence for crop insurance claims and compensations. So now crop insurance is one area where drones are being data collected in drones are becoming very useful. So insurers which are there, they can validate the crop area, yield loss, and extent of damage. And hence the entire process becomes transparent and efficient. And this is primarily I think in the Pradhan Mantri Fasal Bima Yojana, this is it's being used significantly there. That's been there. Then in irrigation and drainage water management, drone equipped with the thermal sensors can detect variability in crop water stress. And accordingly, the precision irrigation scheduling can be done to reduce water wastage. And drone-derived very high-resolution topographic information can help design efficient drainage system, preventing waterlogging in low-lying areas. So overall, it will lead to a better water use efficiency and crop productivity. And it can also be used for drainage and soil conservations to identify erosion-prone zones and monitor the effectiveness of contour bunding or check dams in an area. In flood-prone areas, drone can map drainage planning, can support in mapping the drainage planning and restoration of field hydrology. So overall, for a better, agriculture field management, drones have becoming very handy nowadays. So these are few examples I can show you. It's, as I said, in precision agriculture, we can precisely, wherever is required, water can be given, pesticides, herbicides. So this is one example which is done using drones, which is a field which is infested with the Naramari village, which is infested with the brown plant hopper infested rice fields, which is there. So if you look, the size of the field is very, very small. So from a space-based platform, the small base field will be missed out. So you can look, the red sides are the severely affected rice fields from the brown plant hopper. And accordingly, the spray can be done only in this this small affected areas, whereas this cannot be captured with the space-based observations. This is another example of a wine grapeyard where the the person who owns this can come to know where to harvest first and where to harvest, because this is a large field. Manually surveying it every day becomes difficult. So based on this drone based data which is collected frequently in a week or a day, which he can do and estimate which are the areas which has to be harvested first, so as to prevent the losses. Otherwise what will happen is, if he's delayed by a day or three, the crop may be become it may be damaged. So to that, for proper harvest planning, it can do the survey. Disasters, as I said, they are used in all phases. So this is an example in Nepal earthquake. It was used for rescue and search operations, and also do a post damage assessment. In case of floods in Kerala, it was to to give the relief supply and identify people in areas. In case of forest fire detection and management, they can be used for both equipped with thermal sensors to detect where the mouth of the fire is, and also with the sprays on mount. You can have a sprays on board the drones, mount the sprayer payloads on the drones, and they can effectively reach the areas. And in an area which is not reachable by road or by this, then they can prevent extinguish the fires. So it can be used for effective fire management. So now the question is, choosing the right kind of drone is one thing which is very, very significant. So when selecting the drone, it is necessary to decide what task you are going to do, what is the application is required. So based on that, you would define, you will choose the type of drones, what kind of speed you require, what kind of area, accuracies. So what is the purpose of this? And this is one of the key parameter which is there, that is it determines what is the range you will be able to shoot in a single flight, the flight duration, the maximum flight time, what will be the condition, the temperature ranges, the wind speed. The payload again depends on what is your final application, for what is the purpose. It's agriculture, it's disaster. So what will be the reliability and portability of the drone should also be considered. That is it should be easily carryable to longer distances. It does not require lengthy preparation to start. The material should be light and sturdy, strong, and it is easy carryable to any places. Portability should be high, right? Easy to use, and safety parameters also should be considered by selecting a drone. And then another important fact is the operating conditions. That is the weather conditions in which you need to fly. So drones, the wind speed, the precipitation, air temperature. If you're using drone in a cold area, in a desert-like areas, the temperatures are high. So is the drone sensitive enough to tolerate that temperature? Will it be able to fly, handle that kind of temperature? So all this needs to be pre-decided and tested while buying a drone. And you should have a proper ground control station, which is one of the main features of the drone. It is not only there to do a mission planning, but also to control the entire UAV data collection, which is done with this. So these are the few drone database data processing softwares of drones, which is commercially also developed, mostly commercially available. Some of them are free, but with limited capability, like Open Drone Map Photogrammetry is an open source one, but with the limited capability. Mostly they are COT software, which is available in the market. The cost of the drone is another factor. So that's the manufacturer of it. Then you need to consider, it's not only buying the drone, it's a combination, it's a complete package. You also need to ask for the training part, technical support, warranty. Does it include all the software packages? What is the operation and maintenance cost? Maintainability, the availability of spare parts, and the service life, because there may be damages while flying. So all these parameters also needs to be considered when you purchase a drone. And now I'll quickly give you tell you about the drone rules in India. With the drone rules was formulated in 2021, drone policy, which it provides a legal and an operational framework for flying drones in India. These are updated time to time, and the main aim is to maintain safety, security, and innovation in drone usage. So the main body which is there, the Directorate General of Civil Aviation, under the Ministry of Civil Aviation, is the main authority for drone regulations. The guiding principle of the rules are self-certification, minimum permission, and reduced fees and digital governance, because they're trying to make it more easier. And they have created a platform called Digital Sky Platform. And the main purpose is to make drones accessible and but also ensure safety for all. So as per what I said, in India, there are 5 categories of drones, which is, I mentioned, nano, micro, small, medium, and large. And the permission, basically the classification matters because the requirements of registration, certification, and operation varies across this category. Nano, if it is without a payload, if it is only used for hobbies, does not require any permission, and you can fly. Whereas the other, if you are carrying on board a sensor, requires certain kind of permissions. The larger ones require stringent permissions, which is there. Then in India, they have divided the Indian airspace into 3 zones: the green zone, the yellow zone, and the red zone. The green zones are the ones where the drones can fly up to a altitude of 400 feet above the ground level without prior approval. But near the airport, the limit is around 200 feet. So in the other areas, it's 400 feet you can fly, but closer to the airport, the limit is 200 feet. Within 8 to 12 kilometers of the airport area. The yellow zone is which surrounds controlled airspace such as airports. Here, drone operations require air traffic control clearance, so you need to take clearance from them. And the red zones are the strictly restricted areas. So drones can only be flown here with special permissions from the central government. Otherwise, it's a totally banned zones where you cannot fly the drones. You cannot collect the data in these areas. Then coming to the registration and licensing, like we do buy any vehicle, even drones needs registration and licensing. So most drones except nano and micro, some of the micro drones, if they are used for non-commercial purposes, all the drones are required or need a unique identification number, which is known as UIN. So pilots are also need a pilot certification. Again, nano drones are exempted from these aspects. Then importantly, all drones must comply with a no permission, no takeoff system, which is implemented using the Digital Sky Platform, which means that unless the portal grants you approval, the drones cannot start. They have a inbuilt, all drones which you buy have an NPNT firmware. So this firmware is, unless you get the approval from the Digital Sky Platform, the drones will not operate or will not fly. So this is NPNT compliance, which is there. So this is what is the Digital Sky Platform, which provides the complete, it's a paperless process for getting approvals and registering your drones into the system. So this is what I said. We have 3 space. So green, yellow, and the red zones. The red zones are the restricted zones. Right. So this is, as I said, UIN number is required. This is basically the registration and number which you take. So and the UIN number, as I said, except for the nano drones, all drones are required to be registered and they get a unique identification number. Then pilot certificates are there. You must obtain a license certificate. and this training and from an authorized drone school, and what are the authorized agencies, all the list is available on this Digital Sky platform. Then another aspect is the visual line of sight. So drones generally must be flown in the sight of the pilot. I mean, you should be able to see them unless special permissions are needed. Otherwise, special permissions are required if you want to fly beyond the visual line of sight. So this generally is not provided, but then unless in the special cases, the beyond line of sight permission is required. So the maximum altitude, as I said, is 400 meters, that is 120, 400 feet, that is 120 meters. So now on in future, once the challenges, primarily drones are very handy and useful in various applications. What we saw, the prime challenges is basically the regulations, which is there, the payloads and the trade-offs, which is there, weather and environment, which impact the flight of the drones, data management, because a large volume of data is there, the human capacity, need for a certified pilot training, which is needed. So for each challenge, I mean, there are challenges which is there, but besides these challenges, this drone data, which provide you very, unique kind of information, which can act as a complementary, supplementary to the space-based observations. And with the upcoming technologies like we have AI and edge analytics, so onboard machine learning models can be used for onboard, detecting of real-time feature extraction. This entire drone data can be integrated with the other ground sensors, IoT sensors, for in case of disasters, in case of agricultures. So a lot of things can be done. All trends, there are a lot of trends emerging in the field of drones and processing techniques like AI, ML, which is coming. So drones are very powerful, flexible. I can conclude as a remote sensing platforms. They complement both satellite and airborne system. They enable centimeter scale level mapping. They have a rapid response. They can be fused with different kinds of data combinations can be done. But there are certain challenges, or you can say aspects to it, which is the regulations, the payload limitations, data processing requirements. But I would say in near future, there will be smarter drones which can be integrated with the other sensors, the other ground sensors, IoT platform, and using the AI ML algorithm for onboard data processing. So with this, we conclude with the lecture. And if there are any questions, I would be ready to answer those questions. Thank you. Sensor which you have placed on board the drone. Siddharth has asked, can drones only used to capture the image or processing also? Drones generally capture the images, but using AI ML, we can have onboard data processing. Currently, which is not there, it is under the developmental stage. But in future, we will have drones which can do data collection and onboard data processing. But as of now, primarily they are use for data collection, bringing it down to the ground, and then post-processing. What are the different types of sensors? As I said in my lecture, different sensors we have: simple RGB cameras, or your mobile cameras, or multispectral cameras, thermal sensors. You have hyperspectral sensors, SAR sensors, gas sensors, temperature pressure sensors. So you can have various kind of sensors which can be, depending on your own requirement, which can be placed on board the drones. Image acquisition is nothing, that means data capture. Image acquisition is data capturing. The first aspect of my lecture, which I had mentioned, that the main advantage of using drone as compared to the other two platforms, which I said, remotes, aircraft and satellite, they provide you 1 centimeter to decimeter level of spatial resolution. You can fly as and when you want, right? They provide you very, very high resolution data sets. They can instantly, when you need the data, in terms of whenever in applications like disaster, to assess post-disaster assessment in areas of hilly terrains where you need, whether in areas of shadow where the data is not captured by the satellite platforms, drones can come into handy. Instant data, quick delivery, and that can be complemented, supplemented with the space-based observations. Thank you. If there are no more questions, we would end this session. Thank you so much.